Okay, all right. So we'll resume today. We'll take a little step away from the math a little bit. We'll look at the a little bit higher level concept of participating electricity markets. So what we have been looking at is if you're a central uh, operator, right? If you're a system operator, you're taking all the bits, you solve the optimization problem, you determine the cost. So that's how an operator will work. So now we're going to look at a little bit more from a sort of participant's point of view. For example, if you're a generator or a consumer, how will you think about this process, right? So remember, if you're a system operator, you essentially have a so-called sort of God view. You know everything happening in the system. You can solve the problem, you can determine all the prices. If you're a single generator or a single consumer, you don't have that information, right? So as a generator, you don't know what other people are bidding. You cannot simulate the process of a system operator solving that problem. So your model of the system will be different than say just collect everything together, solve the optimization. Right? So you have a slightly different model. We'll look at how the generator thinks about this. Okay, so the big thing in electricity market is often that you don't have all the information. Oftentimes you don't know what other people are doing. And so we'll look at the sort of generator model. We'll think about what are some of the game theoretical models of participating generators, right? So if you're playing a game, how do you think about this kind of game? And so we'll focus on the generator and then we'll focus on the consumer. We'll look at how should they think about it. So as a generator, the thing to remember is there's three types of generators, there's three types of producers, right? So they're called marginal, inframarginal, extra marginal. The idea is basically the thing again to remember for the power system market, for the energy market, is everything is sold at the same price. Okay, there is only, assuming no congestion, there is only one price at the system, that's a market clearing price. Even if there's congestion, depending on where you are in the system, there's only one price. Okay, so there's not a notion of you can shop around to find a cheaper price. There's just one price determined by basically the last unit sold. Right? So the marginal, so okay, so the marginal producer is basically the producer that produced the last unit, right? So the marginal producer is a special producer. This is the sort of produce the last unit. Right? So this is a special producer. And what happens with this marginal price producer is this is paid as bid. Okay, so if you're a marginal producer, you sold the last unit. So basically your price that you get paid is whatever the price you said you'll sell the last unit at. Right? So you are the producer that determines what the market price is. So again, if you think about the quantity versus price curve, so you have your supply, right? So you have some supply curve like this. You have your demand. This is the demand curve. Then right here, this is basically where the marginal producer is. It produces the exact last unit that was bought to determine the price in the system. So anything lower than here, right? So if your price is lower than the marginal price, you're called an inframarginal, right? So inframarginal means that you're cheaper than the system price, right? So your price, you pay cheaper than this price. So your quantity are all bought at the market and you make some money out here. So for inframarginal, the important thing to remember is you get paid more than your bid, right? So you bid less than this price, you still get paid this price. Okay? Everybody gets paid the same price. So here you actually make some profit. So if you're a marginal producer is not very good. If you're in the system, you do not want to be the marginal producer, right? So it seems like, oh, you're studying the price in the system. In here, it's not like you have a lot of power. You're the guy who breaks even. Everybody cheaper than you actually makes some money, right? So everybody more expensive. So this is extra marginal. Basically, you're more expensive than the marginal price, and nothing happens. Okay, so you're extra marginal. If your price is more expensive than the marginal producer, you're out of the market. Okay, so the idea is, so here, if you're extra marginal, you're out of the market. Right? So you're not participating in this market. It's as if you don't exist for the market. It doesn't matter. You actually bid here, right? So marginal producer sets a price. Anybody sets for cheaper, and the marginal producer makes profit. So this is sort of the idealized picture of the electricity market. This idealized picture, right? So if you're a producer, what is your goal? Let's say you're a producer, where do you want to be? Do you want to be the marginal producer? Do you want to be extra marginal? Do you want to be infra-marginal? Which one do you want? Right? So as a producer, you want to be this side, right? Infra-marginal. The cheaper you are, the better. The assumption in this kind of idealized picture is that basically, right? So what happens is, see, somebody is setting the marginal price. The assumption is if you become cheaper, there's very little impact on the marginal price. And the cheaper you are, the more money you make. Okay, so your goal is not to be on the margin. Your goal is to be as far away from the margin as possible to make the most money. So when we talk about markets, one of the job of a market, of a so-called free market, should be incentivize innovation. Basically, all the producers should have incentive to make their product cheaper. Okay, so that's what we want a market to do. And at least in this idealized picture, you do have an incentive to make your energy cheaper. Okay, your incentive is to be as cheap as possible, therefore get the most profit possible out of this market. Right, so this is a good market design. Right, so if you make yourself more expensive, there is a chance you're out of the market, and you don't make any money. And in this case, it's not that your profit is there. If you're extra marginal, you actually lose money. So why would you lose money if you're extra marginal? Right? So even if you're marginal, you actually lose money. You will have some losses. It's not like you break even. No, it's not that. It's more simpler than that. Simpler than that. So remember what does this price reflect? So remember when you're a producer, you have two types of cost. You have a variable cost, which is reflected by the price. You have a fixed cost that this does not take into account. Right? Your fixed cost is not taking into account in this market. It doesn't matter how much money you spend building your plant. Once it's there, the market doesn't care how much money you spend. Okay, right? So for example, if you're a nuclear power plant bids zero for electricity into the system. It's not that nuclear power plant doesn't cost money to build. As the variable cost of a nuclear power plant is so low compared to everything else is rather zero. Same thing with hydro, same thing with wood, right? So What this reflects, this is actually just a variable cost. Okay, so if you're never in the market, you lose money because you can't make your fixed cost back. Right? You build a plant, you go to make enough money at least to make up your fixed cost. Okay, and right, so you borrow some money, you build your plant, you should earn enough, right? Even ideally with interest, right? So this is really right, so if this is true, then this is really a good market. Okay, the incentive is to be as cheap as possible, right? Every generator is trying to be as cheap as possible to, hopefully increase their own benefit, but by increasing their profit, they're reducing the total cost. Okay, so this is a very good market. We'll see in this class when this doesn't happen. Okay, so this is the idealized picture we had when we, started doing free market or so-called liberal electricity markets. This doesn't always happen. And there's sort of various ways of why this doesn't happen. Okay, so we'll look at some of these in this class. And the first thing to remember is for electricity, the load is not always fixed. There could be a fairly large dynamic range between the peak load, the maximum you have, and the minimum load that you observe during the day. Okay, so this range could be fairly large. This is typically a large, so-called a large dynamic range. And this often causes sort of inefficiencies in the market, right? So this peak depends on different time of the year. This peak happens at different times. So if you're California, typically you have a peak sort of around 7 or 8 p.m. When the sun goes down, you lose solar, and then your load ramps up. For Seattle, this peak sometimes on the winter sort of happens overnight if you're using heating. So this depends on where you are. But right now, what we're seeing is if you have more renewables, this sort of minimum and maximum is getting larger and larger. So in the Midwest, you observe situations where your minimum is essentially zero. So it's not impossible to see a large system where the minimum load is zero or negative. Sort of you paying people to use electricity, or the peak is still high. Okay, so we have quite a bit of dynamic range in the system. So what happens when you have this type of dynamic range is basically your demand curve starts to shift. Okay, so remember, so our demand curve for electricity is quite vertical. It's a fairly vertical curve. And the way this looks is, let's say your maximum load will have a demand curve like that, or peak load. Let's be consistent in this. Your peak load will have a curve like that. And then your minimum load. Right? So this whole thing is you shift this whole demand curve over when you look at the peak and the minimum. Okay. So it's not, so one easy mistake to make is to think of the changing load is changing the slope of this curve. That's not what's happening. Changing load is taking this entire curve and shifting it. Okay, there's not much slope in the demand anyways. The problem with electricity, if you look at this, is not, right? So this is often by no means easier to deal with this, okay? Right, it's not, right? So when you want energy power, if you can't get people power, it's a problem. When nobody wants power, you have too much power, it's still a problem. So minimum load is not necessarily easier to deal with than the maximum load. If you are, for example, if you're wind turbine, most of the time you're not thinking about the peak. With your wind turbine, most of the time you're worrying about how to get rid of power if your load drops. Okay, so there's not the minimum load is more flexible than the maximum load. It's just the whole curve shifts. And then the supply curve is interesting for electricity. The supply curve here, we're going to draw the quantity megawatt hour, dollar per megawatt hour. Okay. So how does this curve look like? What does this curve look like? Is it an increasing curve? Is it a decreasing curve? Is it a very sharp curve? What do you think this looks like? So let's start it off, right? So let's look at this region of the curve. Let's say I have a small amount of generation. Is the price low or high? If I start here, let's start just generating a little bit. This is very low. So this is what's called a base generation. So these generators, right? So this is again as your hydro, your nuclear, other type of generator that's always on. And so they're a very low price. This may be even zero. This may be sort of on this axis. Then what happens is it starts to increase as you run out of sort of base generation. So this is called intermediate generation. This used to be coal, for example. This used to be largely coal. Now this is being phased out. We're having less and less coal. So this region is getting squeezed a bit from both sides, actually. And then what happens is this thing sort of ramps up very vertically. Okay, so there's a supply curve that says, if you need a little bit of power, the price is quite low, start to ramp, and then this is very convex. This is extremely convex curve, and this is called peaking generation. Okay. Anybody know what this field type is? What generator are peaking generators? What type of fuel that is a generator that can be turned on, let's say, relatively fast? Gas is typically around here, right? So sometimes the most expensive one you have is diesel, basically. So diesel is often peaking. Diesel is something you can turn on very fast. It's not super efficient as a generator. And so typically the faster, the more responsive this is, you have a chance of charging more money, peaking generation. Okay, so the thing to remember is, again, this region is quite big. Often like 60, 70% of the power system is base generation. For Seattle, 90% of the generation is base generation. That's just hydro. Okay. Then this is where the price ramps. Okay, so as a system operator, most of your energy or most of your sort of concern, most of your effort is spent thinking about this last like 5% of power, 5-10% of power. Base generation, you don't spend that much thinking about. And the reason you spend time thinking about the last 5% is because even if you look in one day, you can have very large price differences. Okay? So you have your cost curve, something like this, right? So this is megawatt hour, this is price. And you can have this as your peak load. This can be your minimum load or your base load. And the difference between these two prices can be quite large. Okay, so your max, okay, so your maximum price you can see during the day versus the minimum price you can see during the day. This gap can easily be 10 times different. It's not rare to see this. Okay. Any questions about this? Okay. And this is why it's very hard to predict the electricity price. Okay, so one thing that people have been trying to do many, many years is try to forecast electricity price. If you knew what the price will be tomorrow, you can basically make a lot of money. It's like the stock market. If you know what the price will be for tomorrow, you can make quite a bit of money. The reason this is very difficult to forecast is this slope is very short. Right? You can move the load around a little bit. You create a very large difference in price. So 1% of low forecasting error may lead to 20% of price forecasting, this kind of thing, right? So just this line is so much sharper than this line. So that's why forecasting electricity price is by no means easier forecasting the stock price. You sort of small error can lead to large gaps. Okay. And often you exercise market power or the market is not ideal, a lot of times comes down from the sharpness of this price. The idea is if I can move this thing just a tiny bit, I can change the price by a lot, right? Because this thing is so vertical, right? So that's if you're trying to access market power, that's what we're trying to do. We're just trying to shape this curve a little bit one way or the other. And this supply curve comes from just stacking up the offers made by generators, right? So again, to be more explicit, you get this curve. You have megawatt hour, you have dollar per megawatt hour. As you go to the generator, you ask for their price. So this, for example, could be hydro. This could be nuclear, wind, and then this sort of starts to shift up. Here you can have coal, gas, diesel, different kind of generation technologies. Right? So again, this is very large. Most of your system is base generation, right? But that doesn't mean your price doesn't change a lot. Your price change really comes down to what happens here, not so much what happens at the base. Okay, so the electricity system we spend so 90% of the time thinking about 10% of the load. Most of our design choices, most of our market mechanisms deal with rare cases in some sense. We deal with what happens when the system is near its peak. All right, so now you can ask a question, right? So you're a generator, you want to maximize your profit. What should you do, right? Should you're basically, how does this curve look like? As your bid is building this curve, right? So how should you bid? Again, there's no requirement for a generator to bid truthfully, right? That's not, in some sense, not even a defined concept. If you're a generator, you can do whatever you want. You can bid whatever you want. Okay, if you're a hydro generator, nobody says you have to be base load. You can bid very high. If you're nuclear, you can bid very high. Your gas, you can bid as a base generation, right? That's not something that's enforced. And so the question is, what should you do? Okay? Right? So your generator, your entire goal is to maximize your profit. So how should you bid out your profit? Now, of course, this depends on competition. You need to think about how much competition you have in the market. Okay, so this class will look at some sort of very simple competition models of how a generator will compete with each other. Right, so the competition basically lies in a spectrum of possible market structure. So on one end, this is perfect competition. Right, so it means we'll look at technically what it means. On the other end is monopoly. Oligopoly is sort of the middle part. Right, so monopoly is not super interesting in electricity context. If you're a monopoly, you can do whatever you want. Okay, the demand is not flexible. You can set infinite price if you actually have a monopoly in electricity context. So all monopolies in electricity markets are regulated. That essentially means you're a public service. Okay, so we don't have true monopolies. This is regulated in. Okay, so we don't have a true monopoly that can set your price however you want. That's right. So, for example, who's a monopoly? Can you name an example of monopoly? We are all getting our power from a monopoly. Electricity, actually. Okay. Seattle City Light. Seattle City Light is a monopoly, right? There's a monopoly because you have no choice of where you get your power from. You have to get it from Seattle City Light. Right? So you move into a house, that's where your power comes from. If you live in Seattle, right? So it's, by definition, monopoly is a single entity that controls a very important good. You don't really think about it as a monopoly because it's owned by the city, right? So in Right? So you can now vote, basically determine what happened to this monopoly. So all the monopoly we have in the electricity market is regulated. It's basically political entity. Decisions are made not really to maximize your profit. So this is not very interesting. We don't normally talk about monopolies because they're the trivial case. Perfect competition is more interesting. That's in some sense ideal market we want to have. So this is basically all participants are small. And the consequence of all of them being small, they're all price takers. Right? So that's the sort of the nomenclature used for small participants. Price taker means whatever you do have no impact on price. Okay. What your action, your bid, your offer does not change the price at all. So technically what this means, this is the derivative of pi, the price, respect to your action. Right? So this is ICE participants' action. This is zero. Okay, so this is the price, the derivative of the price respect to whatever you do is zero. So you have no impact on the price. This ideal, this is what you want to happen in perfect competition, right? So if you cannot influence the price, all you can do is now to decrease your operating cost, hoping that you make more profit, right? So what this says is, if there's perfect competition, it's perfect. Whatever you do has no influence on the marginal cost, marginal price. Then to make more money, all you can do is be more efficient. So that's the idealized case. This is also sort of more true in textbooks than practice. The perfect competition. The more common or the more realistic case is oligopoly. Oligopoly means that this is you have some influence on price. Okay, so there is the participants have some influence on price. Right? So you're not a monopoly. You cannot just set the price, but your derivative is not also zero. Okay, so you have some positive or not positive, you have some non-zero ability to impact the price. Now here the user are so-called strategic. Okay, so this is now you have strategic bidders. Because when you bid, you have to think about the influence of your bid on the price. Okay? So if you're in perfect competition, the idea is you basically want to sell as much electricity as possible. That's your goal, right? You have no influence on price. Your profit is price times quantity. Price is constant. So to get more money, you increase your quantity. Okay? That's not necessarily true in this case if you're strategic. Right? So if you're strategic, is it always in your benefit to sell as much electricity as possible? Right? So if you know you have influence on the price, would you always maximize your generation? Right. So you won't always try to sell your maximum because if you offer too much electricity, the price may go down. Right? Your total profit is price times quantity. So quantity goes up, price goes down. It's not obvious you should try to maximize your quantity. And this is a difficult problem because that's what often happens if you're wind or solar. Okay, so before going to the math, it's again useful to think about this picture of what happens when you have a lot of wind and solar. Okay, so if you have a lot of wind and solar, what changes to this picture? Right. So if you have let's say right now we don't have that much renewables. Our demand is here, somewhere here. What happens? We have a lot of renewables. What happens to this demand? Right? If you have a lot of renewables, renewables are zero cost. It's as if you're reducing demand. Okay, so you may move from here to here. If you're renewable, would you be happy with this? Right? You won't be happy, right? If I sell you a little bit of power, I can make a lot higher price. Then if I sell you a lot of power, but then my price goes down. Right? So this is a tough problem in integration renewable beyond any of the sort of the engineering problems. As often when you tell people to say integrate solar, solar will naturally be capped at some amount. Because after a certain amount of integration renewables, it doesn't make sense for the renewable producers to increase their production anymore. And just, right? For example, if we can have 100% renewables and you do marginal based pricing, you make zero money. Right? Wind and solar are free. So if everything's 100% renewable, nobody makes any money. Why would you want to build a wind farm? Why would you want to build solar panel? Okay. And we're seeing some of that happening today. As people will integrate up to an extent, then stop. Because you want to make that most money. Right? So that's something to keep in mind when you see this kind of curve. Okay, so right now we're essentially often operating here. And here it makes a lot of difference, right? So this price is quite high, but that's not always the case. Okay, so in this type of market structure, it really is not always obvious, sort of, more production is better. Right? So you can talk about, we want solar to be cheaper, we want wind to be cheaper. To some extent, after a while, it's more of how do you structure the market rather than how cheap can you make this solar panel. Okay, you can make solar panels $0 cost. It doesn't mean we'll have 100% solar. You can make, right? So you can make a negative cost. It doesn't mean you have 100% solar. Okay, so the market will start to sort of matter more and more compared to the technology that we have. Okay, so again, this monopoly is the easiest case. Nothing interesting happens. You either make infinite profit or you regulate it. So next, let's look at perfect competition. Right, so perfect competition is the idea is again that you have sort of small share of the market. You don't influence the market price all that much, and you're all price takers. Okay, so price taker doesn't mean you don't know the price. It doesn't mean you're not forecasting the price. Price taker just means whatever you do has no influence on it. You have no impact on the price. So price to you often appears as this random variable. Right? So tomorrow's price, the electricity price to us, is essentially random. Whatever we do have no impact on prices anywhere in the US. Right? So we still know what the price is. It just as a external number that's sort of given to us. And this makes the calculation easy. And this is again how we recover the marginal price, right? So you think about now you're trying to maximize the amount you can produce. The profit is the price multiplied by your amount minus your cost, right? So that's how we think about it. This is our revenue. This is our cost. We want to have a y that maximizes this. So you take a derivative of this thing, set it to 0. The key thing to remember now is that this pi does not depend on y. So taking a derivative of pi times y is just pi. Okay. Pi is whatever it is. So this becomes pi equals to dcy dy, right? So here, remember that this derivative is 0. So this is we recover that you will produce up to when the marginal cost is equal to the price, right? This is sort of we recover what we had before. So here, since you have no influence on the price, then when you're bidding, would you have incentive to lie? Right? So now let's say you're bidding to the market and you're told, right? So you believe you're small enough that you don't influence the price. Then when you bid into the market, is there an incentive to lie about your true cost? Or would you just tell the operator your true cost? So right? So this is called perfect competition, right? So you still need to tell the operator your true cost. Right? You still need to tell the operator what your true cost is. So here, what happens is, if you're bidding under perfect competition, if you're a price taker, then what happens is everybody will bid your marginal cost of production. There's no incentive to lie. It is not to your benefit to lie. So what happens is the producer will bid the marginal cost, the true marginal. Right? So what you do is you take your own cost, you do this derivative, this is a function of y, you tell this to the generator. You tell the generator, this is my best estimate of what my cost is. So the reason you do this is right? So if you bid the true cost, is that if your marginal or your inframarginal you sort of make a positive profit, right? So if you're basically if you bid your true marginal cost and your marginal, you break even. If you're inframarginal, you make some profit. Okay, you don't at least lose money. Now let's say you were supposed to lie. Let's say you artificially reduce your marginal cost. Let's say your marginal cost was $10 per megawatt hour, but you lied and you tell the operator you actually $8 per megawatt hour. Why is that bad to you? Why is that bad for you? Right? So what happens what happens if you're not truthful? Again, there's nothing in the market requiring you to be truthful. Right? The operator does not check whether you're truthful or not. That's not a requirement. Why would you want to be truthful? Why would you not want to bid, let's say, less than your true marginal cost? What could happen if you bid less? Right? So if you bid less, if your true cost is $10 per megawatt hour, you bid 8. If the market gets clear at $9 per megawatt hour, you're actually in the market. You have to produce in that market. In that case, you're actually losing money, right? So if you artificially lower your marginal cost, you can be in the market more often, but you lose money. There's a situation where you will lose money. If you don't lose money, then it doesn't matter what you bid. You could have be clear anyway. Okay. On the same idea as you never lie to increase your marginal cost. Because let's say if your true cost is 10, you lie, you say you were 12, the market could have get clear at 11. You could have made some money, but you did not. Right? You were out of the market because you lied. I think in this case, it's basically you have choose for bid. Right? So this is right? So you have no incentive to right. So even though the market did not require you to bid truthfully, in this case, it's always to your benefit to bid truthfully, not to lie to the market. Okay? Right. So that's a sort of very advantageous sort of market design, right? Because in this market, your shift is not the market operator's job anymore to make sure people are truthful. People are automatically truthful. It's up to the producer to do their best to figure out what their true marginal cost is. Okay, it's not the market operator's job, right? This was one of the huge reasons for moving to the market system rather than a government-owned monopoly. So in a government-owned monopoly, it is the monopoly, the government's job to make sure each unit operate as efficiently as possible, figure out what the true marginal cost is. That is difficult, right? That is sort of very difficult to do. In this kind of perfect competition, suddenly, if you privatize everything, right, if everything sort of freely can bid, they will automatically bid truthfully and will not lie to you. And you don't have to do any of the work to figure out what the true cost is in your system. Right? So this is one of the reasons why we have an electricity market. So why did Seattle not do that? And California did this, right? PJM did this, MISO did this. Yeah, a lot. New England ISO did this, New York did this. Why did Seattle not do this? Why did Seattle not have a market? So what is special about hydro compared to, say, gas? Right? So for example, you look at PJM, they have a lot of gas and coal, they certainly move into a market. Hydro did not. Right? So the one reason for hydro not having a market is it's hard to, well, it's too easy to operate hydro. Once you build it, your operating cost is essentially zero. You cannot be more efficient. Hydro, it's a lot of capital to construct the hydro system, hydro power plant. Once it's made, operation of hydro power plant is in some sense sort of trivial. You just open the valve. You close open the valve. There's not much to do. You can't make it more efficient. And since we already built a system, it's owned by the government. The hydro system is owned on Columbia River. It's owned by the Army Corps of Engineers. Then, having the operating cost go from 5 cents to 4 cents did not make a difference to the system. Okay, so the hydro was sort of too easy to operate. We had things like gas and coal, where efficient operation actually matters, where you need to design new power plants, then would have gone to a market. Right? Just hydro, once you build it, you're sort of done. You don't need to do anything with the hydro anymore. Okay? So right now, we're starting to be in the California balancing market because we figured out we can make more money by being connected to California. California has more problems. We have a lot of hydro. We can sort of operate our hydro such a way to extract money from California. So we're in that market to make money. But for our own market, again, there's too much hydro. It doesn't make all that much sense to have a market. So we don't have perfect competition, but our marginal costs are so low, it sort of doesn't really matter. Okay, and if you have an inframarginal producer, basically what happens is, right, so let's say the true cost is here, and you get cleared. Let's say your quantity is here. Basically, as an inframarginal producer, you're small, so you make this small slice of profit, right? So this is the marginal price that's being cleared. This is pi. So you're a very small producer, so you have this sort of delta Q quantity here. And this is the amount of money you make, right? So you make the area, your money you make is the amount you produce multiplied by price. We're going to assume you make, your small amount, you're a small producer, to make this much money. And this profit basically have to cover your fixed cost. Okay, so the thing to remember is you need to be inframarginal enough to cover the fixed cost. Okay, right. So it's not that if you're inframarginal, you make the profit over the long run. It's most of these projects, the way they work is that you borrow some money from the bank, you build this project, then you have to pay the money back, right? So you have to make sure that this gap is large enough to cover all that. Yeah. So the finance of this is complicated. That's sort of the whole field of study of, you want to get into it. What's the interest rate? How do you do this kind of calculation? Here, just suffices to remember that, you have some incentive to be infra marginal. You want to make some money out of this. Okay, so if you're a marginal producer, what happens is you basically have, right, so you're here, this is the true price, and this is your bid, your marginal, delta Q, pi. If you're marginal, you make no profit, you make no money. And being marginal is not very good. Okay, so if you're too often being marginal, then you're doing something not very efficiently in the market. Okay, you want to lower your price. Right, so there's a saying that you sometimes hear for the market is you want to be marginal because you're setting the price. That's not true in a perfect competition. In perfect competition, you don't want to be marginal. You're marginal means you're doing a bad job. You're losing money because you cannot cover your fixed cost. You want to be inframarginal enough. What is true that if you're in this kind of oligopoly, this is where you want to be marginal. You actually, if you're marginal here, you actually have some power of making more money. Okay, so whether you want to be the marginal price or not, whether you want to be setting the market price or not, again, depends on competition, depending how many other people are in the market with you, right? So let's take a break, then 5-minute break, then we'll look at what happens in this case. We have some ability to impact the price. Okay, so I'll take a break, then we'll look at, if you're here, how do you make more money? By sort of strategically bidding, not your true cost, but something else. Okay, all right, so let's get back to this case, right? Let's look at when this is not true, what happens. There you have incentive to lie, right? So there you will lie. And the reason is, again, is because this thing is very short. So what you want is you want to just, take advantage of this little change here. Okay? So if you look at, again, two possibilities is you could have a peak demand being here. This is where you cross. Right? So you could have, your normal peak prices being here. You could have shift this thing a little bit and suddenly your price will jump a lot. So this, for example, this could be a summer day that was hotter than normal by a couple of degrees. We have sort of more air conditioning load, maybe just 5% more load. Again, this price could jump by 20-fold. Okay, so all this could happen. All right, so we have price spikes. And then we have something called the sort of the normal price. And then now it's become sort of more interesting to study this kind of extreme price. So you want to think about an example of the true system like this, think of Texas. The Texas system has a habit of the price going from $40 per megawatt hour to $1,000 in a few hours. So Texas will do this. Right, again, because you're hitting this part. Right, so, and there's nothing in the market that this cannot happen. Again, this curve is built up by the bids from all the producers. There's nothing limiting them from doing this. Like, this is just what the curve looks like in electricity. You see this in practice, right? So this is taken from PJM a bit earlier, but the system price is not very different now. You can look at the mean price, you can look at the peaks. Okay, so the peaks could go to 1,000. Why does not across 1,000? It doesn't cross 1,000 because we cap it at 1,000. So you cannot go over 1,000. Anything higher is capped at 1,000. Okay, that's just a rule that's in the system. So this one, for example, all those peaks essentially will be at a delta if you're not capping it. Okay? So you can have things like, the price is 30, goes to 1,000, comes back to 30, an hour later, goes to 1,000 again, this kind of thing. Okay, so this are all the spikes. And if you just look at the spikes, and if you knew where the spikes are, you could have made essentially infinite money out of this. If you had the thing like a storage. Right? So let's say you have storage, or even you're doing virtual bidding. If you knew these are the price that will happen, you can make a lot of money, depending on where you charge and discharge your storage. The tricky thing again, this spikes largely appears random. Okay? So if you time this thing wrong by an hour, you could lose money. Okay, the difficult thing in the power system, these things are just random spikes that comes out. It's not like the price is high, will be high for a while, right? So even the stock market price looks better than this. If it rises, will rise for a day, it falls, will fall for a day. This thing is just essentially random spikes. This is a random spike train that happens. A very good model for this spikes is every time you flip a coin, like you say my coin has a probability of 1 in 10 to give you 1,000 spikes. That's actually a perfectly good stochastic model for this. We don't have a better stochastic model. It's just a random spike train. Okay. And this is the kind of reason, right? So if your load has a very small change, your price has this drastic jump, basically jumping between these 2 points. Okay. Right? So if you have an algorithm, right? So you can build some AI algorithm that will forecast this kind of peaks with any kind of accuracy. You can do better than a random guess. You can make a lot of money in the market. Right now, the problem is, given all the sophisticated technology we have, right? ChatGPT can write poetry. It cannot guess better than somebody flip a coin for the price. Right? There's some sort of just intrinsically very hard to forecast. Okay, so the holy grail of energy price forecasting is getting a handle on this. Not perfect. Just do 10% better than a random coin flip. You can make quite a bit of money if you can do that. Right, so this is where the game is, but we don't. Right, so it's just again very hard to forecast. This is actually the true price curve. This is true price duration curve for PJM over a year. So what shows you is this is the percentage of hours in 1 year for the system. This is the price. Okay, so for example, 60. For 60% of the hours, the price is less than 25. Okay, for some hours, the price is very, very low. Right? So, but again, this thing keeps going up because for some hours you go to 1,000. Okay, so again, if you're making money in the system or you're paying money, most of your cost actually happens for a very small number of hours. This is not super interesting. This gets way more interesting once you're here and you can graph it. Okay? So PJM actually has a price peak, price cap at 1,000. Again, Texas do not believe in price caps. So Texas, in principle, you could have a price that goes to something like $1 million per megawatt hour. It's conceivable. The system will allow you to do that. You want to enter that into the system, it will allow you to enter that into the system. Okay, so Texas does not cap. Every other market in the US will cap it. Okay, so, but again, anyways, your goal is just to get this peaks correct. Can you get the peaks right? Okay. So given this, basically, if you're a firm of any size, right? If you're a firm of any size, you're basically thinking, can I exercise on market power? Okay, you're not if you're even if you're sort of being intelligent about this, you will not just pay your true cost. The idea being again the following is right. So if you're a firm, if you're a generator, how do you get this to look like that? Like how will you get this thing to look like this? I said the true load is here. You really want the price increase. You really want to shift the true load this way. How we do that as a generator? Right, so this is June as a load. As a PSO, based on wherever the load is, the price will change. But as a generator, could you, induce this shift? Right. So what you can do is instead of shifting demand, you can try to shift this red curve to the left. Right. So let's say you're a nuclear generator, generating base load. Let's say by accident, half of your generator went offline. Then what happened? This whole red curve shifts to the left. You can go from here to here, right? As if the load increased. Okay, right? So it does, right? So you could play this game even though you're base generation. You don't have to be on the margin, right? Like if you're nuclear, if just happens you cannot generate that day, it doesn't mean you're losing money. You could get very lucky and make 20 times more money by generating less. Okay, because how sharp this curve is. And this is an example of market power. Basically, market power, two things can happen. One is reducing output. Right? This is called physical withholding. It's saying, I have two generators, I'm just going to offer you one of them. The hoping is that the price increase will make up for you having less quantity. Okay? Another is just to say you just increase offer price. Okay, I'm going to guess without me, you don't have enough other generators to have perfect competition, so I'm going to increase my offer price. This is where your incentive to loss, right? You're not bidding your true offer cost. You could do this. Again, both of these two are legal. There's nothing illegal about it. You're not forced to bid everything into the market. These are perfectly legal things to do. Okay, right? So what example of this thing is, let's say a firm generates 10 megawatt to megawatt hour at $15 per megawatt hour. Okay, so let's say this you're a firm, you're figuring on this out. There are basically two options. One hope is to generate 9 megawatt hour, and for the price to go up. Right? So your hope is by generating a bit less. Let's say if you generate a 9, the price goes to $20 per megawatt hour, you made more money, even if you generate less. Right? So this is good. So here you're not a price taker anymore, right? This is by you're assuming your action would materially impact the price. Okay? You're basically assuming this. Another option you have is simply to bid more than bid at a higher price. Right? Bid per megawatt hour. Okay, so these are the two choices you can have. If you believe whatever you do could impact the market, you probably do one of these. Right? In some sense, if you don't do this, you're doing a very bad job for your generator. Your role as a generator is to maximize the money you get. Okay, so this is nothing. Again, there's nothing wrong with doing. You should be doing this if you're a generator. If you're not doing this, you're not doing a very good job. It is up to the market to design the market in such a way that doing this is not beneficial to you. If doing this is beneficial to you, it's up to you to do whatever you want. Right? Your job is simply to maximize your profit. Okay, there's nothing illegal or nothing wrong about this. If you're an investor-owned generator, if you're not doing this, you probably got fired. Right? So it's your job to maximize price here. And the idea again is the reason you can shift by reducing supply is basically again, right? So if you have a normal supply, this is your normal supply, and they intersect here. What you can do is you can have a reduced supply and intersect a much higher price, right? So this is reduced. So you can either increase the load or you can drag the supply lower. Right? So this is something that's completely legal to do in the market. Right? So again, all this depends on whether you're good at forecasting this kind of spike. Okay. So again, the thing to remember for this kind of spikes is, right? So why could you not see the spike, then do something? Right? Can you observe the market and figure out, hey, the price is really high, let me do something. Right? Why can you not do that? Right? So the reason you cannot do this is the price is determined after you make your bid. Okay, you have to make your bid first, then the price is computed. You don't get to see the price, then change your bid. Okay, you submit your bid, the price is found, then your bid is final. Okay, you have, you basically you enter into a contract, you have to do whatever you say you're gonna do. Okay, so it'll be very easy if you can see this and determine your bid. The problem is it goes the other way. You bid, then the price gets clear. Then what often happens here between these two, for example, this sort of double peak says some people bid, price is very high. A lot of people enter the market thinking you have a high price. That drives the price lower. When people leave, then the price shoots up again. This sort of eventually, settles down. Okay, so there's a timing issue here. There's because the sequence is the price is the outcome of your action. Right? You have to do your action first and see the price. You cannot peek ahead. You don't have the ability to peek ahead. Yeah, so that's again why this is hard. This is essentially driven by the collective behavior of a few hundred large generators in this thing. So that's why again it's not a truly random process. It's sort of driven by enough people, so it appears very random. Yeah, go ahead. So this is centralized clearing, but it doesn't matter. If you do bilateral contract, right? So if your contract is cleared exactly, then you're okay. This price is relevant to you. There's mismatch, you're still paying at this price. Right. So often you enter into bilateral contract, that's because you don't want to deal with this. Right. Let's say you're a utility, you're buying load. And suddenly you happen to look at, you buy load at, you're serving load at the wrong time. You lose money. Right? So could happen. So bilateral trading is a way to hedge against this. But again, in the US, we don't have that much bilateral trading compared to Europe. Because if you show people this plot, and you and I try to enter a bilateral trade, that's sort of impossible to understand what that shit is. There is some risk, whether risk to you or to me or who is this risk to, we don't know. Right? So that's sort of the hard thing is, people argue over this, right? But really, it would be better if this thing is less random. But right now, all these prices are looking more random than before. Yeah, so that's where a lot of, yeah. So again, be very good if some of you come up with a forecasting algorithm for this. It would be, but just difficult. Even it's difficult even to describe this. Like even stochastic model is even hard to describe this. Like what exactly is this? We don't have many random processes that looks like this. It is hard to think about this thing. Okay, so let's do some calculation. The calculation we do is the following. So if you have market power, the way to think about it is following is you have yi. So this is your production of generator I. You have a capital Y, this is a summation of all the producers. So now what happens is you're still maximizing. The thing you're trying to maximize now is the price. So the price depends on the summation, right? Depends on what everybody does. Depends on the sum times however much you have produced, subtract your cost. This doesn't change. You're trying to maximize this. The change is now when you take a derivative, this is no longer the derivative respect to of the price respect to y is no longer zero. There's some derivative that's not zero. So if you take a derivative, what you have is this pi. You have a product rule. This is not zero, so you have to carry this term around. Okay. So you have this extra term that sticks out here. Again, you can try to solve this thing when it's zero. So we're going to put, so here on this side, we're going to put your marginal cost. Okay, we're going to put your marginal cost here. We're going to pull out this price. Okay, so remember, if you're a price taker, this is it. Right? If you're a price taker, this is it. We just have this term, the price. Now we have additional terms. We're going to write 1 plus yi over y. This is just sort of rearranging the terms. Okay, so this is the way we'll write this. This is basically. Okay, so that's just the way we'll write it. This will think of this is your influence on the price. So this is nothing but a sort of derivative. Let's write it now this way. Sorry, let me. Right, so this yi over y. This is y over dy di. Okay, so this is just extra term. So this term, sort of the right term cancel, you'll get this. But this is thinking of, so this is a fraction you have out of the entire production. This is how much you can influence the production, this elasticity of the price. Right? So this is, if you collect some terms, what you get is basically, what you get is you get the marginal cost is equal to the marginal price in the system over something 1 minus SI, where this thing is this is the price elasticity. Okay, so the exact definition is not all that important. The more important thing is to observe that basically what happens is you will be in the market. This is a negative, right? So basically it says you basically modify the apparent marginal price to you. Okay, so this is your marginal price appear to you as a smaller number. Okay, so this is a positive number, this is less than 1. So to you, the marginal price is smaller. So at the optimal production, you have some influence to the marginal price. Okay, so instead of just producing up to the marginal price, now you have to think about what is the elasticity of the market, how much you should produce to influence this elasticity. Okay, so this is the idea of having some influence. The key thing is you typically don't know all this kind of numbers. You don't know all this constant. You don't know the elasticity of the market. You don't know what other people are doing. There's sort of a lot of other people, you don't know what they're doing. Okay. But if you knew perfectly, this is what you would do. And the idea is this tends to happen quite a bit in electricity market. Electricity market is far from a perfect market. It's far, far from a perfect market. We have demand does not have a very high elasticity. Demand is very stiff. Supply does not have a very high elasticity. A lot of generators typically cannot change their output all that fast. So if you are let's say if you're a generator that can change your output very quickly, then in principle you have a lot of market power, right? So, but again, the thing is, it's very hard to time it correctly. The whole thing is very hard to time it correctly. And for people with storage, one of the sort of most obvious thing to use storage for is price arbitrage. Right? You charge when the price is low, you discharge when the price is high. not exploring market power. In a perfectly efficient market, you cannot do arbitrage. You should not have this kind of opportunity. In the electricity market, obviously, you have this kind of opportunities. The idea is, again, it's very hard to time it. It's very hard to get an idea what the peak is. So often you make money because of random luck, because you just happen to hit it exactly correct. But that just depends on what you do, right? It depends on whether you can time it correctly. Okay. So to mitigate market power, there are sort of two things you can do. One is just to make the demand more flexible. So you increase demand flexibility, or increase demand elasticity. So if your demand is not that stiff, then if your producer changes and the demand could change at the same time, your price will come down. So this is demand response. Right. So another thing is basically is to increase the number of competitors. Right. So if there's a lot of competitors, then you hope that each of them will have sort of relatively sort of small amount of ability to influence market power, then market will be more efficient. This is hard to do. This is fairly hard to do for demand response. Again, you have to time it correctly for demand response. The increased competitor is basically what the market does today. So remember, if you're a generator, you can lie about your marginal cost. You can do withholding either physically or economically. All those are completely fine. Those are completely legal. So if you're a generator, there's sort of basically one thing that's not legal. If you think about what is the one thing that you cannot do as producers in the market? Right. So the only thing you cannot do as a producer is that you cannot have collusion. Collusion is the only thing that's not allowed. Right. What collusion does is basically a group of generators gets together and not effectively reduce the number of competitors. Right. So if I can, get all the generators together to act as a group, then you can increase the profit. So the thing to remember for this kind of market power is exercising market power is beneficial to everybody. Even if you're hydro, you're bidding on space load, will be beneficial to you if somebody else is exercising market power. Okay, for all producers, if you're happy if somebody is exercising market power, right? Your base load, you're very happy somebody exercises market power, price went up. Okay, so that's something you're happy about. So this is unlike some other market where people exercising market power may squeeze other producers out of the market. Here is every producer is happy if somebody else can manipulate the price. Okay, so there's a natural incentive for collusion. And as a system operator, you spend a lot of your time looking for collusion. Okay, so for every system operator, there's a huge team of people whose whole job is to look at all the generators' bids to detect whether there's collusion going on or not. You try to figure out there's a colluding, if there are two generators that are bidding in sync with each other. If a peer say no, one knows the other one will have a maintenance, this kind of thing, right? So thing to remember is the only thing you cannot do is you cannot collude. Everything else is fine. Okay? Everything else you can do whatever you want as a generator. Okay, so there will be limit to the number of generators you can own. There will be limits, right? You cannot communicate with other generators, for example, but everything else is fine for a generator. Okay. All right, so today we'll stop here. We'll look at the more high-level view of market power. Friday, we'll look at two specific models of competition. We'll formalize this sort of, if you change your production, how the price will change, we'll formalize this too. There's sort of two common model of competition we'll look at, and that will give us a way of computing. For example, if you're wind, why might there be a sort of maximum amount you want to sell to the market? Okay, so we'll do that on Friday.